Okay, so with rationalizing the denominator, there's two different cases. If the denominator is, that stands for denominator, D-E-N, and make a little chart. If denominator is just square root of something, so just square root, no number on the outside, you're going to multiply the top and bottom by whatever that denominator is underneath the square root. Now, if the denominator is not a square root, so say if it has some number right here, like 3 or 4 or 5, and then B should have an exponent always. If it's not there, it's what? The exponent. 1. Good. So if it's this in the denominator, you're going to multiply by same root, except you're going to take B to the n minus x is what you're going to multiply it by. So that's two different situations.
You said the denominator is square root, you can multiply by the square root.
Yes. But if it has a different root, like 3, 4, 5, 6, we'll use this formula. But before we rationalize the denominator, we always want to make sure we can't simplify anything. Okay? So for number 1, square root of 2 and square root of 6. Can we simplify the square root of 2? Are there any perfect squares that go into it?
No.
What about 6? Any perfect squares that go into 6? So we cannot simplify it. And this is a square root on bottom, right? So we're going to multiply the top and bottom by the denominator, which is square root of 6. And here's why we do that. We can't have a radical in the bottom, right? And y'all had a lot of trouble remembering, like, square root of 6 times square root of 6 is what? 6. Y'all had a trouble remembering that, right? So here is why the square root of 6 times the square root of 6 equals 6. Square root of 6, let's write this as in exponential form, okay? So this is 6 to the 1/2, right? Times 6 to the 1/2. You don't have to write this part down. What happens when we multiply something with the same base? We do what with the exponents? We add them. So this is 6 to the what power? What's 1/2 plus 1/2? 1. Everybody see why the square root of 6 times the square root of 6 is 6? We add the exponents, it gives us 1. That's why we multiply the top and bottom by square root of 6, to get rid of that denominator, that radical. So again, what's going to happen when we multiply square root of 6 times square root of 6? We'll get 6, right? And then these up top will be square root of what? Somebody said it. 12. You just multiply these and leave it under the square root. Are we done, you think, with this problem? Because why? We can simplify what? Square root of 12, right? So we can rewrite square root of 12 as what? Good. 4 times 3 over 6. And then what can we take out? And what's the square root of 4? Thank you. Plus or minus 2. What has to stay underneath the radical? All over. Are we done? No, we can simplify it, right? What two numbers can we simplify? 2 and 6, right? The numbers on the outside, not underneath the radical. Okay, so what goes into 2 and 6? So we can rewrite this as plus or minus
3,
square root of 3 over 2. Very good. We have simplified it because there's no radical in the denominator anymore. So 2 in the bottom.
Why is there 2 on the bottom?
From right here, because 2 goes into 2 one time, so that's a 1 right here. 2 goes into 6 3 times. Thank you. Very good. Yes, because 2 goes into 6 3 times.
Why did you multiply it by 6 over 6?
Talking about right here?
Yes.
Anything you do to the top, you got to do to the bottom.
Okay.
And we multiply it by the bottom so the square roots can cancel out. We never want to have a radical in the denominator. Okay. Any other questions about that one? Alright, for this one, they're both underneath the square root. If it makes it easier for you, you can rewrite it like this. Square root of n cubed over square root of 8. If it bothers you that they're all under one root, you can rewrite it like that. And now we check, can we simplify either one? Can we simplify square root of n cubed? Can we simplify square root of 8?
No. 8.
Yeah, we can simplify square root of n cubed and 8, right? What we've been doing in the yesterday. So look at this one, the square root of n cubed. 2 can't go into 3, but 2 can go into what? N squared, right? So we can write this as n squared times what? N. Everybody see what I did there? And we can write square root of 8 as square root of what? Good. Now let's simplify. This would be n squared over 2. That would give us what? N. Right? Everybody see that? Square root of n squared is n. What has to say underneath the radical? N. On bottom, what's the square root of 4? And we can put the plus or minus out front, but I'll wait till the end to do that.
Why does the other have to go into the square root?
Because this is a 2 right here, Zach, right?
Yeah.
So this would be n to the 1/2. And we can't have fraction exponents, so that's why it has to stay underneath. Now this one was 2 over 2. And it gave us 1, right? That's why we could bring it on the outside.
Wait, where'd you get that? 2.
On bottom, square root of 4.
Oh, the other side.
Right here? Right here?
I'm square root.
This?
No, like under the n, square root of n, divided by 2.
Yeah.
Yes.
This?
Yep. That.
We haven't finished this part.
Oh, okay.
I just stopped and answered his question. Okay, so this would be square root of what? 2. Good. Sorry, I had no idea what you were talking about. I just didn't finish it because I answered Zach's question. Okie dokie. So now we got to get rid of this square root of 2, correct? Alright, so we can multiply the top and bottom by 2 square root of 2, the whole denominator, because these are together. Alright, let's do the bottom first. Okay? Let's multiply what's on the outside of the radicals together first. That would be what? Yeah, let me draw this. 4. And also, what's square root of 2 times square root of 2? 2. So we have 4 times 2 on bottom.
But you got the 4 by multiplying this bottom 2.
Yeah, these 2 together make 4. These 2 together make what? 2. Again, these 2 together, 2 times 2 is 4. Square root of 2 times square root of 2 is 2. That's where I got those. Alright, now on top, let's go ahead and multiply what's out front together, just like we did here. So that would be what? 2n, and then underneath the radical would be square root of 2n. Very good. And now we can just clean it up. Alright, can we simplify this 2n underneath the radical? No, there's no perfect squares in 2, and this n has an exponent of what? 1. So we can just leave the top alone, 2n square root of 2n. On bottom we'll have 8. And then the last thing we need to do is just simplify these two numbers, right? So what goes into 2 and 8? Alright, so on top we'll have n square root of 2n over, very good. They're not hard, just a lot of attention to detail, just like the ones we did before
You
yesterday.
have the n by simplifying 2 and 8.
Yes, 2n divided by 2 would just be n, 8 divided by 2 would be 4. Alright, next one. Do I need to break this up, or can y'all tell that these are both just under square roots? We need to break it up, or no? No? Okay, cool. Let's go ahead and simplify then. Can we simplify the top part? Yes. What's a perfect square that can go into 32? 16 times. Good. And on bottom, what happens here with this square root? If we take the square root of t to the 4th, it'd just be t squared, right? So we can just leave this as square root of t to the 4th over 2. So on top, what's the square root of 16?
4.
Plus or minus 4. What has to stay underneath the radical? 2, and what's going to be on bottom? Good. Are we done? What else could we do? We're done. There's no radical on the bottom, and there's no numbers you can simplify. We are done. That was easy. Alright, one more together, then you can do some on your own. Questions so far? Alright, this is where it gets tricky. What's different about this one? Yeah, there's no square root, right? So we've been doing, if the denominator is square root of b, we multiply by square root of b. Now we have a number other than 2 right here, so we're going to have to use this formula. Okay. And I'll tell you why in just a second. Let's rewrite this as 4 square root of 6 over 4 square root of 5x. I'm just breaking it up. What is our n in this problem? 4. What is our x? The x is the exponent of this, which is 1. Good. So again, our n is 4. Our x is the exponent of this, which is 1. So we are going to multiply the top and bottom by 4 square root of 5x to the 4 minus 1, which is 3. Good. Same thing up top. 4 cube root of 5x cubed. Now, one thing we need to do is put this in parentheses, the 5x. And let me explain why. These two are together, right? So this 5x, this whole thing's being raised to the first power. This whole thing's being raised to the third power, right? That includes the 5 and the x. They're not separate, they're together. The reason we have to do this, the reason we use this formula and don't write this part down, this is 5x raised to the what power? Over? Good. We're putting it in exponential form. And then this is times 5x raised to the what? Good. And remember, we keep the same base, add the exponents. So if we do this, this will be 5x raised to the what power? 4 over 4, which is 1. That's why we do this, to get rid of the radical. We have to use this formula if it's not a square root. If we were to do 5x to the 1/4 times itself, 5x to the 1/4, this would give us 5x to the what power? 2 over 4, which is 1/2. So this would really be square root of 5x. We wouldn't have gotten rid of the radical. Everybody see that?
Yeah.
Okay. You don't need to write that part down. I was just showing you. Alright, so the bottom part, we know we're going to get what? We just saw that. 5x, right? On top right here, they have the same root, right? 4. So we can write the 4 square root of 6, and I'm going to put times, because this 5 is not 5, right? It's 5 what? Okay, it's 5x what? Cubed, which means I have to cube the 5 and the x, correct? So what is 5 cubed? Somebody tell me. You say that? 125. So this will be 6 times 125x cubed. Everybody see that? How I got that? I just cubed each term in here and brought it down. The 6 came from right here. Yeah. The 5x cubed, that means we're cubing both terms. So 5 cubed would be 125. X cubed would be x cubed. The 6 came from right here. Alright, so it's 125 times 6. 750x cubed over 5x. Are there any quartic roots that can go into 750? Y'all know what quartic roots are? It's something that you can raise to the 4th power. Like perfect squares are like 4, 9, 16, right? Perfect cubes are like 8, 64. Y'all know where I get 8 from. 2 cubed. 3 cubed would be 27. Those are perfect cubes. So perfect quartics, I guess that's what you would call it, is something you can raise to the 4th power. So start with the smallest number. 425. That wouldn't be a quartic root. What's 2 raised to the 4th power? Start with the smallest number. 16. So 16 would be the smallest perfect quartic root. So can 16 divide into 750 evenly? Nope. All right, then let's start with the second quartic root. What's 3 raised to the 4th power? 81. Can 81 divide into 750? All right, try 5 to the 4th power. What's that going to be?
625.
Can 625 go into 750? Nope. So do you think we can simplify that? Yep, we're done.
Keep going this way.
Like the part I was just talking about?
Like all of it.
All of it. Okay. This part, if it has something other than a 2, which it does, it has a 4, we're going to take this formula. So we're going to multiply the top and bottom by, this would stay 4, and then 4 minus whatever this exponent is, which was 1. So 4 minus 1 is 3. So we multiply the top and bottom. When we do this, the reason we do this is because all the radicals go away, and you'll just have 5x. On top, we just multiplied what's underneath the 4th root together. So 6 times, this was 5 cubed, 125, x cubed, this is x cubed. And when we multiplied these together, we got 750 x cubed. And we couldn't simplify it, so we left it like that. Do we need to do one more like that? Okay. Y'all are good with these kind, with just the square root? Okay. So that will be which one out of 1, 2, and 3?
2.
Number 2. Yeah, let's go ahead and get that one together. Then you can do 3 and 1 and 3 on your own. All right, the 5th root of, let's go ahead and rewrite it. 5th root of 3 over 5th root of 4y. And again, why do we have to use this special formula? When do we use this? Y'all got to know when we use it. Good. When there's not a square root. When it's another number, right? Like 5. What is our n in this problem? 5. What is our x? 1. The exponent, not the coefficient. Both of these are raised to the what power, even though it's not there? 1. So we're going to, go ahead.
Your x is your power. Like whatever's been raised to.
Yeah. This is your power, this is your root.
Okay.
So we're going to multiply top and bottom by 5 square root of 4y, and this is going to be raised to the what power? 4. Same thing up here. 5th root of 4y to the 4th power. So really the exponent's just 1 less than whatever your root is every time.
Where'd you get the 4 from?
The formula n minus x. Our n in this one is 5. Our x was 1, so 5 minus 1 gives us 4. Alright, and on bottom, what happens? What's the point of doing this? All the radicals cancel, so what's going to be left on the bottom? 4y. Good. Just what's underneath. And then on top, they both have the same root, so we can put all of it underneath the 5th root. And this will be 3 times, the 3 came from here. And we'll do 4 raised to the 4th power, which is, what is it? 256. And then y raised to the 4th power would just be y to the 4th. Any questions so far?
Okay, like at the bottom when you got 4y,
Mm-hmm.
it's because 5 minus 4 is 1, and that's 4y raised to 1.
Yeah, if we want to write this out, Chloe, we could write, this would be 4y raised to the what power?
From
First over,
5.
good. I'm going to write that over here. You don't have to write it. So 4y raised to the, again, it's 1 over 5, right? Times, we're multiplying it by 4y raised to the what power? No, 1 over 5. What is it?
4 over 5.
Yeah, the exponent 4 over 5. So we'd keep the same base, 4y. When we add these, it would be what?
5 over 5.
Which is? Good. See how these are the same?
How do you get the 3 times?
Oh, the 3 came from here, Zach. We just brought this down. The 256 came from 4 to the 4th power. and y to the 4th power. So that came from raising 4 to the 4th power right here. Alright, from here we can multiply 3 times 256. That's going to give us what? 768 y to the 4th over 4y. And now we need to check if there's any quintic, I guess you would call it, quintic roots that can go into 768. So always start with the smallest number. The smallest number is what? 2. I'm talking about just the smallest number besides 1. That's what? 2. Raise 2 to the 5th power in the calculator. Tell me what you get. What now? 32. Okay, see if 32 can divide into 6.
24 times.
24? Alright, then we can rewrite it as 5th power of, what was that again? 32 times what? 24 y to the 4th over 4y. And again, what was the 5th root, or which one's a quintic root, 32 or 24? And what is the 5th root of 32? What now? 2. Good. So we can bring that out. Do you think there's any quintic roots that go into 24? No, not if the smallest one's 32, right? So we can leave this underneath. We can't do anything with y to the 4th because can 5 go into 4? No, it's bigger than that. So we can just leave y to the 4th underneath. And a 4y. Let me stop there. Does anybody have any questions about that part?
Why can't you define do 768 to the
1/5 power? Try it. Tell me what you get.
It does.
Yeah. That means that same thing as if we had like square root of 48. The square root of 48 is a decimal, right? But there's perfect squares that can go into 48 and we can break it up. Just like this one. And now, are we done here? No. What goes into 2 and 4? 2. So the top would be what? Square root of 24 y to the 4th over 2y. Perfect.
You don't have to put plus or minus.
On this one,
Yeah.
this was what kind of root?
Oh, yeah.
Odd, so we don't have to put plus or minus.
What happened to the 5?
Right here? I just forgot to put it. Thank you. Alright, try 1 and 3 on your own. And I'll give you about 5 minutes and then we'll play Kahoot. As soon as everybody finishes 1 and 3. Please let me know if you need help.
I don't think I understand.
This just means that this is square root, so if no numbers on the outside, you can just multiply the top and bottom by the bottom. If it's something other than 2, like this one had 4 right, and this one had 5, then you can use this method to multiply the top and bottom by. So this one is square root. Yeah. So all you have to do is multiply the top and bottom by the denominator, which is what? So the bottom would just be what? In the top? No, you can combine. You can't add the exponents because they're different bases, but you can write them beside each other. Yep, and now you'll simplify it. Is what's on the outside here? Good. So you can't go into 9, but it can go to what? There you go. Yeah. That one. You can, or you can simplify it again. Either way. So just that one, clean this up first, so you get this part exactly right, so this would be to the left. If you take the square root of 2, and then you have square root of 8 over square root of. Yes, now you want to call the top and bottom by. Yes. So multiply these two first, what's on the outside, so these here times these here. Go ahead, write that somewhere. And then what would be the square root of b times the square root of b? Write that beside it. And on top, what is a to the 4 times b squared? You can't combine them and line them beside each other, right? B squared. And you say square root of. Good job. And now just typing the square root of both sides. Then you can just multiply that by square. And now combine those two. So that's easy. Good job.
So this would be b to the 5th, good, but these two are underneath square roots, right?
Oh.
Now simplify these. So this is the squared on the outside, right? So 2 can't go into 9, but it can go into, good, rewrite them, just the top part is simplified.
I have to do some top now. So this is the square root, right? So 2 can't go into 9, but it can go into, so you rewrite it as a 0 times. Don't understand this. And so this is 0 times. And now this one. Let's start off with next. They have different bases. So on top you have the square root of a to the 9. You can write them both under one letter. Yeah, so you can copy this one. So you can go around it to the and now just going to copy the top. And when we know that is, this is 0, and then 2 takes on the 9, but it can go into, just put those up on top. What those are bottom is in the next, you need to, simplify this part. You can't do that because it's underneath the radical. But you can split square root of 40 up, right? Let's put square root of 40. Can't 4 go in there? 4? Good, so it'd be 4 times 10 x, right? Over 8, so square root of 4. And then square root of what? Over, now just clean that up. Very good. You guys can probably talk. You got what? Okay, you can simplify first word at the end, doesn't matter. You can see it's
Okay, let's quickly go over these, then we'll play our Kahoot game. Alright, for the first one, how many of y'all simplified first? Okay, so y'all just multiplied it. That's fine, we can simplify at the end. So I'll write it up here. Square root of a to the 9th over b to the 5th. So y'all multiplied both by b to the square root of b to the 5th, right? So on the bottom we'll get, oh gosh, on bottom we'll get what? B to the 5th, good. Out of the radical. On top, we can't combine these because these are different bases, but I can write square root of a to the 9th, b to the 5th, right? And now all you have to do is simplify the top. This is a square root. So 2 can't go into 9, but it can go into what? So we can rewrite this as a to the 8th a, right? Everybody see that? I just broke this up. And then b to the 5th, we can split it up as what? Times. Good. All over it. b 5th. So what's the square root of a to the 8th? Good. What about this one? Good. So that'd be square root of AB, good, over no, because these are just variables. And we could really simplify it more than this. Because what's on top and bottom? A B, right? And how can we simplify these two? How do we divide? Subtract their exponents, right? So 2 minus 5 would be b to the 3rd, right? It'd be negative 3. So we'd have to move it on what? Bottom. So your final answer should have been a to the 4th. That b cancels out because we just subtracted them. Square root of ab over b to the what? 3rd.
So you're gonna write, and also if we don't simplify it on the.
Maybe.
Can you explain that? How you find that?
Yeah, the b's right here, we can combine them, and when we divide b's, we subtract their what? Exponents. So 2 minus 5 is negative 3. So to make it positive, I moved it to the bottom.
What if there was an A on top and you simplify it?
Alright, we're running out of time, so we'll go ahead and play the game. If you'll go ahead and get out your phone. But your homework tonight is 7 through 10. 7 through 10. You can play in groups, but only groups of 2, no more than 2. Whoever wins can draw out of the box. I'll give you 2 minutes to sign up. And if we don't get to finish it before the class ends, it's whoever is in first will get the prize. Anybody need more time? Everybody's in? You in, Jackson? Take your time. Okay. Alright, here we go.
Teacher, students, please excuse this interruption. I have an announcement for Miss Craig's 4th period class. Those students in Miss Craig's 4th period class, you will need to report to the library at the beginning of 4th period, and you will go to C lunch. 4th period Miss Craig's class will go to the library at the beginning of 4th and report to C lunch. Thank you.
I should have set the timer shorter. Who has an answer? Do y'all have an answer? Okay. Good. Most people got that one. Ooh. Last one. Everybody answer quick. Hurry. Y'all have a great day. Alright, Jared and CJ. Jared, you want your prize or no?
I'll get it. I'll bet you. We can CJ one too.
No.
I'll take CJ.